When you connect a fixture directly to a building's main soil stack, you are linking it to a network carrying hazardous biological waste. Under normal conditions, gravity pulls that waste away. But if a blockage occurs downstream, the system pressurizes, and that contaminated wastewater will reverse course, flooding directly back into whatever is attached to it. Welcome to this specialized technical deep dive. I am engineer James Bolo, and together with the JCB EDU Build Solutions team, we are going to deconstruct the exact mechanics of plumbing isolation. Standard plumbing design operates on a primary axiom. Fixtures must have a direct, sealed connection to the building's sanitary drainage system to safely remove human waste. However, there are specific applications where a direct connection introduces an unacceptable safety hazard. If a sewer line backs up into a hospital sterilizer or a restaurant's food preparation sink, the resulting contamination is immediate. In these scenarios, the National Plumbing Code prohibits a direct connection. This review will map the exact thresholds the code uses to manage these exceptions. We will analyze indirect wastes, the rules for wet venting, and special wastes, to examine how the National Plumbing Code maintains system integrity. Rote memorization of dimensions and pipe sizes will fail on complex board exam questions. Developing the necessary proficiency requires understanding the core engineering intent, specifically how the code uses hydraulic isolation and structural oversizing to replace standard venting and direct drainage. We begin with the concept of an indirect waste system. Instead of a continuous pipe leading to the sewer, the physical connection is severed. The wastewater discharges through an air gap, falling freely into a separate receptor that is connected to the drainage system. Section 803 dictates indirect waste pipes under 4.6 meters need no vent, but those over 1.5 meters must be trapped. Section 804.1 details receptors. A clothes washer standpipe must extend 0.45 to 0.8 meters above a trap roughed in 15 centimeters above the floor. These indirect setups, complete with air gaps, are mandatory for fixtures where contamination is unacceptable. This includes sterile appliances in hospitals, commercial dishwashing machines, and culinary sinks used for soaking or preparing ready-to-serve food. These specific lengths and heights represent the exact limits of fluid dynamics where gravity drainage operates safely without a vent, successfully isolating the primary system from back pressure. The second category involves mechanical and clear water wastes. This encompasses discharge from air conditioning units, swimming pools, and boilers, systems that produce wastewater but not human excreta. Because this water does not contain solid waste, the code dictates that air conditioning condensate waste pipes must remain independent of any sanitary drainage system. The requirements change for fuel-burning condensing appliances. This text from Section 807.3 shows that the condensate produced by these systems is acidic. Because of this, the code mandates corrosion-resistant materials like cast iron, galvanized iron, or approved plastics for the drainage piping. Pay attention to the exceptions. Section 807.3.1 explicitly notes that if this condensate is discharged into an exposed fixture tailpiece and trap, those specific components are permitted to be made of brass. In mechanical wastes, the primary threat is material degradation. The acidic nature of clear water waste can damage building infrastructure, making strict isolation and specific material codes vital. We now address architectural limitations. When designing a kitchen island or a multi-story open atrium, installing a conventional dry vent pipe straight up through the roof is often impossible. The first workaround is vertical wet venting. Section 812.1 restricts this to 4 fixtures on the same floor level, receiving 1 to 2 fixture units. To compensate for shared air and wastewater, the wet vented section must be oversized by at least 1 pipe size. When standard systems are structurally precluded, the code allows a different workaround, the combination waste and vent system. Looking at Section 814.3, we see the mathematical relationship required to ensure free circulation of air. The minimum area of the vent installed in this system must be at least 1/2 the inside cross-sectional area of the drain pipe it serves. Because this system limits the number of vents, Section 814.4 mandates oversizing. Every waste pipe and trap in a combination waste and vent system must be at least 2 pipe sizes larger than standard code requirements. The engineering logic here is geometric. By increasing the pipe diameter by 2 sizes, you ensure that wastewater will never fill the entire pipe. This creates an unbroken layer of air above the flow line, effectively substituting geometric capacity for a dedicated dry vent. The final category is chemical wastes. Effluent from laboratories or industrial processes requires total isolation from the standard sanitary network. This section of the code outlines the extreme material resilience required. Pipes receiving acid or corrosive chemicals must be constructed from chemical-resistant glass-lined pipe, high silicon iron, or lead pipe with a wall thickness of at least 3.2 millimeters. Furthermore, Section 811.6 dictates no chemical vent shall ever connect to or intersect with vents serving other building services. Due to associated risks, the administrative authority requires owners to maintain a permanent record of all chemical waste and venting piping locations. The code treats chemical wastes as a parallel ecosystem. It cannot share venting, it cannot share materials, and it cannot directly connect to the building's primary plumbing at any point above ground. We have navigated the 4 environments where standard direct connections are overridden: indirect setups, mechanical discharge, structural workarounds, and chemical isolation. This matrix consolidates the required metrics. You have the 1.5 to 4.6 meter thresholds for indirect wastes, the air gaps and acid-resistant material specs for mechanical, the 2 pipe size oversizing rule for combination waste in vent systems, and the total system isolation required for chemical networks. The core philosophy driving these requirements remains constant. When a direct connection introduces a hazard or is physically impossible, the National Plumbing Code relies on physical air gaps to prevent contamination and geometric oversizing to maintain atmospheric pressure. On behalf of engineer James Bolo and the JCB EduBuild Solutions team, thank you for joining this deep dive. Anchoring these specific code numbers to their engineering intent provides the technical proficiency required to pass the Master Plumber licensure exam.